Hi everyone, I am B. Venkatanagasaran. I am pursuing B.Tech from JBIT College, and this is our final year major project. Our major project is on the topic of healthcare system, and the title of the major project is time optimization techniques for the X-ray angiogram using ML. So we are using machine learning. So for finding the blockages in the X-ray angiogram. And we are also using the image computer vision, so for finding the blockage in the images. So we are using the libraries like Matplotlib and OpenCV for completing our project. With the help of that two libraries, we have completed our project successfully, and our code is on Python. So we will introduce the images from the hard disk and our system to the code, and then we can run. So this is our code. Our code is having of 10 steps. In every step we will introduce a thing, so that that is used to help our project to complete. So in the first step we are going to introduce the image to the code. So when we run the module, so it's starting. This is the image. We want to find the blockage in the X-ray angiogram. This is X-ray angiogram image. So for finding that, this is the original image. We are getting this image into the Python code by using the path of that. By entering the path of that in the code, we can get the image into the code. So next step is to Step 2 is to crop the image borders with 10% and the pixel count. So after reducing the image by 10%, this is the pixel count, how many pixels are present in that image, that will be shown in here. So this is the pixel count. And the step 3 is to convert the image into the grayscale. So for reducing the color complications, we are converting our X-ray angiogram into the grayscale to get the accurate results. By using the grayscale, we can remove the noise, reduce the noise which is occurred due to the salt and pepper noise in the image processing. So step 4 is to apply the brightness to the grayscale. So the brightness is allocated to every single pixel. So this is the normal image before brightness correction, and this is the correction of the brightness. So we can see the image which is before brightness correction and after the brightness correction. In this, the vessels are brightened, and we can see the accurate results by this. And the further steps are continued by my friend Dheeraj.
My name is Dheeraj. I am currently pursuing 4th year in JBIT College of Engineering. And now let's continue to the 5th step. Now if we see here, this is the output of the 4th step. Now here all the information is being brightened over the area near the veins and the arteries. Now this is the blurred image. We apply median blur to get this image. Here if we see, the arteries and the veins are more brightened than compared to the surrounding areas. And now if we look at here, the wanted and unwanted information both are being presented at the same brightness level. But if we see here, the parts we got, like the alls and the batteries, they are being highlighted, while the other parts are being not downsized to excluding the information. Now let's move on to the next step, that is creating threshold. Now see, this creates creating adaptive thresholding means giving the image to the pixels, so we can differentiate the pixels to identify the blockages between them. And now here we see these grid lines are created using 12 boxes and yields a total of 132 pixels. Now we apply the adaptive threshold. This is the blurred image, and now we are converting the image into arithmetic edge image and arithmetic Gaussian image. Now if we see here, this highlights the borders of the arteries, and this gives a more detailed image of the borderings. Now through this we can get counters which highlights the borders, which is step 8. See, we are using counters to get it. It converts the arithmetic edge image into CV2 morph rectifier and CV2 morph cross to CV2 morph ellipse, which if we see here, that the arteries are not detailed around here much. But if you see on the next two images, this gives more information, and this gives the finite limited information which we want to diagnose the patient. And now let's move on to the next step. This is the counter image, and this after we applying threshold counter, there are 2 points in applying threshold counter. If the image have a threshold more than the counter point, then it will black the image, and if the threshold is less than the counter, then it will white the image, just as here. Here the threshold is less than the counter point, and here the threshold is more. So this is blackened and this is white. And now we get the final step. If you look at here, this is the last picture of the countered image, and after that the machine by which is trained by the given data sets we have already done, this will point out by circling this. If you look at here, this is more than, this is blockage. But if you look at it, this seems like blockage, but they are not, because these are some other arteries which are overlapping over the current arteries from which we are diagnosing. So these are not considered as a blockages. So here this is the only part which got detected by the machine algorithm. So it was circled.
Thank you.
I thank JBID for presenting me this opportunity, and I like to hand over to
Thank you for giving us this opportunity, and this is our project. Finally, we can find the possible blockage by using this algorithm. Thank you everyone. I hope you like it.